Find theta in equilibrium position. This is a real work which is moving with the acceleration a, and the pendulum is clamped at point this. Mass of bob is m, and it is making angle theta. Case 1. Inertial frame, that is from ground. The LVD of bob with respect to ground is, consider in this there will be a angle. If tension in the string is T, then the direction of T will be in this direction, and the weight of the body will be bob will be in vertically downward direction. So we have two components, one is T cos theta and another is T sin theta. Now, because this body is moving with acceleration a, so we can write sigma fy equals to 0, that is T cos theta equals to mg, because there is no motion in the y direction, and sigma fx equals to m into ax, or hence T sin theta equals to m into a. This equation 2. So dividing equation 2 by 1, we get tan theta equals to a by g, or theta equals to tan inverse a by g. Now second case, if we consider the non-inertial frame, that is bus, that is person is sitting, person is watching the box from the bus, the ability of body will be, that is real force plus a pseudo force. Then we have to apply a pseudo force in the opposite direction. So this is the pseudo force, mass into acceleration. Now this is the tension, and we have component T cos theta and T sin theta, and the weight of the body is in downward direction, because from frame of the bus, um, bob is in rest. So we have sigma fy equal to 0, T cos theta equal to mg equation 1, and sigma fx equal to 0, T sin theta equals to ma. Dividing 2 by 1, we get tan theta equal to a by g, or this implies theta is equal to tan inverse a by g. Second case, find acceleration of the block with respect to wedge. This is wedge and this is the block, and it is said that friction is absent between these, and the whole system is moving with the acceleration a in upward direction with respect to ground. Let a not be the acceleration of block with respect to edge, that is non-inertial frame, then FBT of block will be real force plus pseudo force, because acceleration, the frame acceleration in this direction, so pseudo force will be in this direction. So it is shown here. Now m into g plus a sin theta, because pseudo force in this direction may mg, because this is theta, so it will be also theta. So in this direction, the component of this plus this will be mg, m into g plus a into sin theta, and so we can write, because this is moving in this direction, so minus, we are taking x direction as this and y direction as this. So in this direction will be negative, and this direction will be positive. For this direction will be positive, and this direction will be negative. So minus of m into g plus a sin theta equals to m into minus of a naught. Hence a naught will be equals to g plus a into sin theta answer. Next, what force is exerted by the block A on the block B? two blocks are placed in the lift and lift is going in downward direction with acceleration A as shown in the figure. Mass of A is given 0.5. Now seeing it from the inertial frame, that is ground frame. Now FBD of A. This is from the FBD of a normal force due to this body will be in upward direction, and mass of the body will be in this direction, and because whole body is moving with acceleration in downward, so this body also will be moving in downward direction. So it is shown acceleration. So we can write sigma Fy equal to m into Ay, or ma into g minus n equals to ma into A. Equation of answer. So n equal to ma into g minus A, putting value ma given 0.5 into 10 minus 2 equals to 0.5 into 8 equals to 4 Newton. Now FBD of B. On this body there will be two normal force, one due to the lift surface and one due to the block A. Block A exerts a normal force in downward direction and lift will exert in upward direction. And there will be a mass weight of B in downward direction. This is shown here. That is N is in downward direction and N dash due to surface of lift in upward direction and V. Now we can write the equation of motion. FBD of B is shown, so we can write n plus mb into g minus n dash equal to mb into A, or this imply n dash equal to n plus mb into g minus A. So force exerted by A on B equals to n equals to 4 Newton. From the non-inertial frame, that is from the elevator or lift, because in the with respect to lift, both body is in rest and the lift is moving with acceleration in the downward direction. So we have to make this frame inertial. We have to apply force in upward direction. So we are applying a force in the upward direction, that is pseudo force. So FBD of D has to be FBD of D, or FBD of A first, real plus pseudo force. So there will be a normal due to body B and a FP pseudo force MA into A and weight of the body MA into G. Since block is in rest in this frame, so we can write hence n plus Fp equal to Ma into G, or n equal to Ma into G minus Fp, Mb into G minus Ma into, or n equal to Ma into G minus A, 0.5 into 10 minus 2, 0.5 into 8 equal to 4 Newton. Now for FBD of B, again weight in downward direction, normal force due to surface of lift in upward direction, and normal force due to block A in downward direction, and pseudo force in upward direction, which is equal to md into A. And now again this block is in rest, so we can write n dash plus n mb into A, that is pseudo force, equals to weight plus n plus m into G. So n dash equal to n plus mb into G minus A. Now n is the force exerted by block A on B, that is n equal to 4 Newton itself. This is another situation. Again, an elevator is going upward with the acceleration A, and a pendulum is hanging in this with a string in this elevator. Solving this problem, analyzing the problem with respect to inertial frame that is on ground. So FBD of pop will be, there will be a tension in the upward direction, weight will be in downward direction, and pseudo force will be in downward direction, because the frame acceleration in this direction, so pseudo force will be in this direction. So we can write T minus mg T minus mg equals to m. Yeah? Oh, sorry. This is the, we are seeing it from the, because we have considered inertial frame. So we are seeing the body from the ground. So there is a tension in the upward direction, weight in the downward direction, and this body is moving with acceleration in upward direction. So T minus mg equals to m. Yeah? This is shown here. Or T equal to m into g plus a, or equals to 0.05 into 9.8 plus 1.2 into 0.05 into 11 equals to 0.55 Newton. Now from the non-inertial frame, that is observer seeing the bob from the lift, then lift will be, because lift is non-inertial, so we have to make it inertial to apply, so we should apply a pseudo force in the downward direction. In this frame bob is at rest, so we can write T equals to the free body diagram shown here, Fp plus mg, m into m mg or m into a plus g, solving we get to 0.5 meters, same as above. The method is same as above, only put a equal to minus 1.2 meter per second. Above equation we get T equal to 0.430 meter. See, now V equals to constant, so A will be 0. So sigma y equals to 0 or T equals to mg. So the value of T will come like this. T, inertial frame, body is moving now in downward direction. So sigma y from inertial frame into a y, mg minus T equal to m, mg minus so T equal to m into g minus a. So think we get 0.430 Newton. Now from non-inertial frame, in this frame bob is at rest, so sigma y equal to 0. So T plus m equals to mg, hence T equal to m into g minus a. Again we get the same relation. See, put a equals to minus 1 by 2 in the above equation, we get T equal to 0.55 meter. F sigma y equal to 0, hence T equal to mg equal to 0.44 meter. Let A is the magnitude of acceleration and deceleration. Here it is shown the situation. When the lift is accelerating, A is positive, that is in upward direction going. Now solving the problem from non-inertial frame, that is from elevator, the FBD of M will be real plus pseudo force and pseudo force in downward direction and weight of the body in downward direction. Now body is in rest in this frame, so we can write N equal to Ma plus Mg or M into A plus G, that is maximum weight of the man, because M measures the weight of the man. So this will be the maximum weight of the man. When the lift is decelerating, A is negative, hence N dash equals to M into minus A plus G or M into G minus A. This is the minimum weight of the man. From problem, M into A plus G equal to 72 into G and M into G minus A equal to 16 into G. Solving, we get 2mg equal to this value, so M equal to 66 kg. Now from 1 A equal to 72 into G by M minus G, 72 G minus mg by M, or 72 G minus 66 G by M, 72 minus 66 into G by M, solving 0.9 meter per second square. Next, find the reading of the spring balance, that is given M1 into 1.5 kg, M2 is equal to 3 kg. This is the spring balance. Body is hanging string with pulley system and the whole system, that is lift, is moving upward with the acceleration A. Non-inertial frame elevator, let the acceleration of M2 with respect to elevator be A naught, downward, then acceleration of m will be in upward direction. Now FBT of m1, we have to apply pseudo force here, that is real pseudo force. So the free body diagram will be T in upward direction, and pseudo force Ft in the downward m1 into A, because lift is moving with A in downward direction, and weight of the body in downward direction. So we can write T minus m1 into A plus G equals to m1 into A naught. Again FBT of m2, m2G plus m2A, minus 2 into m2 into A naught. Adding 1 and 2, we get minus m1 into A plus G plus m2 into A plus G equals to m2, m1 plus m2 into A naught. From it we get A naught equals to m2 minus m1 into under bracket A plus G divided by m1 plus m2. This is equation 3. Now from 1, T equals to m1 into under bracket A plus G plus A naught, putting the value of A naught, m1 into A plus G plus m2 minus m1 into A plus G divided by m1 plus m2, or m1 equals to 2m2A m1 into under bracket 2m2 into A plus 2m2G divided by m1 plus, or 2m1 and 2m2 into under bracket A plus G divided by m1 plus m2, question 4. Now FBT of pulley, there is a tension T dash, and tension in steam is T. So we can write T, and also pulley is moving. We can apply a that is pseudo force Ft, mass of pulley is in downward direction, m pulley into A, and this will be equal to 0. So T dash equal to Pt plus Mp into A, or equals to Pt, because Mp mass of pulley is 0. So T dash is equal to 2 into T, equation 5. So reading of a spring balance equals to T dash equals to 2 into T equals to 4 into M1 into M2 into A plus G by M1 plus M2. 4 M1 into M2 into G by 10 plus G equals divided by M1 plus M2, 4 M1 into M2 by M1 plus M2 11 G by 10. Solving, finally we get 4.4 TJ area 44 Newton.